Hello, ladies and gents, coming to you once again, not quite live, from One Take Studios, where we are talking about writing equations of lines today. This is a topic that I know is taught by a lot of people, a lot of textbooks, all that kind of fun stuff. I would like to give, I guess, a slightly different approach to it. I'm asking you to think things through. It is possible to actually understand these things instead of memorize them, and so we're going to see if we can make that happen, at least for some parts of this, all right? I'm not going to do a whole lot to try to explain the tried and true, except for the fact that its name actually makes a ton of sense. Ladies and gentlemen, if we're going to write equations of lines, slope-intercept form is the most popular form that is out there. If you ask anybody, this is one of the few things that they can remember from their algebra classes. Y equals mx plus b. All right, so star form, boom, right there. Y equals mx plus b. It is called slope-intercept form because, well, you have to know the slope to use that, and it also helps to have the y-intercept, so it makes use of both of those things. This is also a really useful form for graphing, so slope-intercept form has a lot of application for it. Real simply then, if I'm looking at this, saying, all right, I've got an example, I have a line, the slope of this line is 4, I've been told that, and the y-intercept is -7. Using this is really simple to put together. We're not going to overthink it too much here, all right? So we are talking along the lines of y equals, wherever I have a circle, I need a number. What was the slope? 4. Great, awesome, wonderful. Times x plus, well, that's going to be my y-intercept. I'm going to put in a -7. You can put plus a -7 if you like, but there we go. That's it. That's my equation. I'm done. Boom. Okay. I'm not teaching this from brand new scratch, by the way. If anybody's looking, like, if you've never seen this before, you should probably find a different video right now. But, okay, so we can do this. We can do this no problem, right? Why are we doing this? What if the slope is 5 and goes to the point -1, 3? I know a whole slew of people on this planet that still use slope-intercept form with this given knowledge. It makes sense to use slope-intercept here because I have the slope and the y-intercept. This, every time somebody takes and tries to force the slope-intercept form when you're using a slope and a point, I've seen so many kids, they drop pieces out of their brain, they don't quite know what they're doing, it doesn't stick super well. Can I just please recommend a very overlooked form? All right, point-slope form is a real thing. Right here, point-slope form. All right, so this is also a delightful option, if I don't say so myself. So here's the one, boom, here's the other, boom, there we go. Why would I have interest in point-slope form? Well, oftentimes I have a point and a slope, and somehow point-slope form would make sense. My slope is still m, there's my 5. Here's the point that I have. So again, wherever I have a circle here, I'm going to go ahead and plug a number in. This is y minus y sub 1. Okay? Y minus. What's my y value for my point? My y value is 3. Awesome. There we go. Equals, slope was 5, we'll put a 5 there, times x minus, again just following this form, what is the x coordinate for my point? That was -1. Ooh, minus -1. Can I put plus? There we go. Ladies and gentlemen, that is a perfectly legitimate equation for a line. And I get a whole bunch of people like, oh, poo-poo to you, that's not in slope-intercept form. It could be if I wanted it to be. I could distribute the 5 and add 3. That wouldn't take me that long. But this makes more sense to a lot of people to construct it than to try to force this knowledge into this form. So there are two forms for writing equations that are helpful. Please consider this one, if you don't mind. The fight that most people put up against point-slope form is they look at it and it's just this crazy mess of letters. This is not like somebody waved a magic wand and this thing showed up. I want you to think just for a second about the formula for slope. Slope is going to be, what is that? That's y sub 2 minus y sub 1, just squeezing it tiny in the corner for comparison's sake here, over x sub 2 minus x sub 1. I'll go into more detail about why this makes sense on the next page, but I want you to think about this. Look at this dude right here, okay? And then look at point-slope form. What happens if I take my x sub 2 minus x sub 1 and I multiply both sides by x sub 2 minus x sub 1? It's going to look an awful lot like that, and this is going to look an awful lot like this. Point-slope form is simply a rearrangement of our slope formula. So it doesn't have mystical origins, somebody just rearranged it. We don't want to plug in, like for slope, we actually plug in 2 x's and 2 y's. We don't want that here because we actually would like to have an x or y in our equation because that's what makes it an actual equation that is graphable, something that we can work with. If we plug in all numbers here, we have a beautiful true statement, but it's not the equation of a line. So having variables is a good idea. All right, so kind of keep that in mind. We have options. Dun, dun, dun. And okay, so a couple more examples of things here. Let us say that we have a line that goes through this time 2 points. Let me see my screen a little bit better. There we go. And it goes through the points -4, 3, and -1, 9. All right, so this is different from previous examples. First we had a slope and an intercept. That was easy enough. Then we had a slope and a point. That's still pretty easy. Now we have 2 points. Ooh, whatever shall we do? Well, notice what both of these have in common. They both require slope. And so if we're going to write an equation for a line, that's a great place to start. We have to find the slope for it. So can you take a look at this with me, please? All right. Slope is rise over run. This is another thing that a lot of people have stuck in their brain, which is a good thing. And hopefully it means something to you because that's what slope really is. It's a comparison. How high do I go versus how far do I go? It's just a ratio. So why is this our formula for slope? Well, think about rise. If you're rising, that's an up-down direction, yes? If I graphed something, which axis goes up and down? The y-axis. What does subtraction give us? Distance. All this is asking for right here is how far am I rising? That's why it's y sub 2 minus y sub 1, just trying to find the distance that we are rising. Over, well, okay, same thing for run. Run implies left-right type of movement, all right? So if we're running, and the x-axis is the one that goes left and right, and again, if we subtract 2 numbers, we are finding the distance between them. So this is how far are we running, the distance. Rise over run, change in y over change in x. There's our equation. So if we use that with this, we've got going on here, m is equal to, watch your positives and negatives, because a lot of people just don't fully tune into that and make some silly mistakes. I'm going to break tradition. I'm going to do 3 minus 9. Some of you are going, oh, don't do that. Don't do 3 minus 9 because this says y sub 2 minus y sub 1. Yeah, it does. But as long as I'm consistent, if I want to do 3 minus 9, I can. But then I have to do -4 minus -1. -4 minus -1. And this will work out just peachy keen. Equals, let's see, 3 minus 9 is going to be -6 over, what do we have here? -4 minus -1, so it's -4 plus 1, so really watch your signs. That is -3, which equals 2. There's my slope. Okay, so this is the formula that we are working with right now. Great, now we have a slope. Now what do we do? Well, again, my recommendation would be, I have the slope, and I have 2 points. Can't I still use point-slope form? But wait, I only need 1 point. Pick one. Which one do you like? They both work. I'm going to pick the first one because why not? So that's going to be y minus 3. So it's going to be y minus the y value there equals, my slope I just said was 2. And then we've got x minus the x value, which is -4. So x minus -4, I'm going to call that plus 4 because that's the way that I like to write it. Ladies and gents, that's my equation right there. Ta-da! Some of you might be saying, but if I used the other point, it would look different. It would. It would say y minus 9 equals 2 times x plus 1. You know what, though? If I multiply, let's say I distribute this 2, this is going to be 2x plus 8, right? And then I add 3. What's 8 plus 3? 11. What if I had these in here? If I had the 1 here, that would be, if I distribute, that would give me a 2, and then I would add 9, and oh my gosh, I would still have a y-intercept of 11, and I would still have a slope of 2. These lead to the same road. You can't pick a wrong point. Decide on which one you like. Go with it. Again, if I want to change this to this form, I can, and I can do it easily. So I do really like point-slope form. All right, time to mess with your brain a little bit because that's always something that I enjoy. What if we go ahead and do this problem right here? All right, so take a second, pause, try to work it through, see what you come up with. Well, that's kind of weird. I don't know if I like that. I mean, it's -2 minus -2 for finding my slope because I need a slope. But -2 minus -2 is 0. And 5 minus 8 is -3. What does that mean? A lot of people actually don't know what that means. That is 0. 0 divided by -3 is 0. What does that mean for my equation? It means that the slope is 0. Can I still use one of these delightful forms? Absolutely I can. Can I ask you to look at something though? I want you to look right here. I want you to look right here. What do you see? They both have a y value of -2. What if I thought about a little tiny mini sketch of these things? Because what would that look like? That would be tiny baby sketch. So here's, let's call this 5, -2, that's here, and then let's call this 8, -2, and that's here. What kind of a line is this? This is horizontal, which should make sense that it has a slope of 0 because it's a horizontal line, and like the sun setting on the horizon, the slope here is always going to be 0. What's the equation for a horizontal line? It's one of the simplest things that people mess up left, right, and sideways. They both have a y value of -2. My equation is y equals -2. Done. If I recognize this and I know what's happening, I don't even have to find the slope. I simply know what I am doing. Y equals -2. Think about this. What happens if I go back here and my slope is 0? This is gone. What do I have? Y equals whatever my intercept's going to be. Same thing over here. What happens if my slope ends up being, if my slope ends up being 0? This whole chunk goes away, all of this, and I'm left with just y minus a number equals 0. Keep your eyes open. Think about what's happening. Last one. What about this one? If I start it the way I started the last one, which I can do, I'm going to go 6 minus -8 over 4 minus 4. 6 minus -8, that's 6 plus 8, that's 14 over 0. Here's what, again, a lot of people just can't completely grasp. What is this? If 0 divided by -3 is 0, surely that means that 14 divided by 0 is 0. Nope, 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 nope. It doesn't mean that at all. This is undefined. It does not have a value. I can't divide something into 0 groups. Let's think for a second. I have 14 marbles. I would like to put them into 0 groups. Can I make the marbles not exist? Ooh, I know. What if I just throw all the marbles out the window and then oh wait, but they'll still exist. I can't put them in 0 groups because now they're in a group on the ground outside the window. This is not possible. It cannot be done. And so again, if people aren't paying attention really to what they're looking at, they struggle significantly because both of these equations require that I have a slope, and this has no slope. This is 0. This is no slope at all. But again, eyes open. I'm hoping you already caught it. What's right here and what's right here? If this one was horizontal, because both the y's were the same, guess what this one is? Vertical. Both the x values are 4. X equals 4. Done. That's my equation. It's the equation of a vertical line. So I put these in here because they are really straightforward, but really people struggle to keep them in their brains. We spend most of our time doing stuff more like this. All right, so I hope this at least gives you an idea of how to get going on stuff like this. Try to think it through. Memorizing just does not stick well with people's brains overall, so try to make sure that you are understanding what is happening in life as much as possible. All right, thanks. Have fun.